Today's our topic is hybridization. What is hybridization? Mixing of
Two orbitals.
Formation of
New orbitals having
with identical shape and energy. Understood? Who gave this concept? Pauli. Pauli gave this concept, hybridization. So what is hybridization? Mixing of orbitals, formation of
New orbitals
with identical
shape and energy.
It is called hybridization. And the orbit which form are called hybrid orbit. So this hybridization we divide it into three according to your syllabus. SP, SP2 and SP3. Now we are taking this example of SP, SP2, SP3. You all know very well what is the shape of the orbital S?
Spherical.
What is the shape of the P orbital?
Dumbbell.
Px, Py, P orbital take part in this type of hybridization. Okay, so now first of all you have to know what is the percentage
50-50.
contribution of
50-50.
S and P. So how you have to calculate? 1s and 1p. It means how many orbitals take part? 2. So what is the contribution of
50%.
S percentage?
100 by
2. 1 upon 2 into 100, it means S contribution
50%.
is 50% and P contribution is
50%.
50%. Got it? Say yes or no? Yes. Okay. Now let's switch to another type of hybridization, sp2 hybridization. So in sp2 hybridization, one s orbital and two
P
p
orbitals.
orbitals. So see how many orbitals here take part in
3.
hybridization? 3. So what is the contribution?
33.3%.
S is equals to, you have to put in formula and then you have to find out. 1 upon 3
3 into 100. 33.3.
It means how much it is?
33.3%.
33.3%. And P contribution, you have to subtract this from 100. It means 2 by 3 into 100. It means it is 66.6%. Got it? Say yes or no? Now let's come to sp3 hybridization. So 1s and 3p. It means overall how many orbitals take part? 4. Out of this, what is the contribution of S? 1 upon 4 into 100. It means it contributes 25% and P contributes 70 upon 4 into 100 is equals to 75%. Okay, got it? Say yes or no, so it is clear to all.
Yes.
So in hybridization, what are the conditions for hybridization? So number 1, only valency shell electron participate in hybridization with nearly almost same energy. Okay, no too much difference in their energy. Clear? And new orbital which form have equivalent energy and identical shape. So this is the condition. So who gave this? Pauli. The form orbitals are called hybrid orbitals. And the process is called hybridization. In hybridization, it is not always only half-filled orbitals take part, empty orbital takes part, or fully filled orbital takes part. So in hybridization, empty orbitals, half-filled orbitals, and full-filled orbitals take part. Clear to all? Now let's take one example related to SP, SP2 and SP3 hybridization. So best example of SP hybridization, we have to take BeH2. Clear to all? Say yes or no? BeH2. It's your choice. If you want to take BeF2 or BeCl2, you have to take it. Now listen here. How many electrons present in beryllium? How many electrons beryllium? 4. What what is its electronic configuration?
1s2, 2s2.
1s2 and 2s2. And is second shell having P also? Say yes or no. First shell having S, second shell having S and P. This having P, but it is empty. But it is empty. So first of all, we have to fill this beta according to this. The lowest energy 1s. Then we move to beta 2s and also 2p. Am I right? Say yes or no. Am I right? Say yes or no. 2p also present. Say yes or no.
Yes, ma'am.
Clear? This is called what beta? Ground state. When this beryllium from ground state moves to which state beta? Excited state. So what will happen? One of the electron, yes please, from S move to P. So this is 1s, this is 2s and this is 2p. Now which type of hybridization beta? sp. So what is the difference in their energy? Say yes or no. 2s less energy in comparison to that of 2p. So during hybridization what will happen? Change of energy. Formation of new orbital with identical energy and identical shape. So see here. This do not take part. So as it is in its position, this take part and this take part. So when they mix, what will happen? Its energy increases and its energy decreases. So what will happen? You have to make this orbital here and leave these two here, which were empty. So which type of hybridization takes place? sp. And you know very well S is spherical, P is double. Now they change their shape. So S change its shape like this. Why this? One lobe is bigger and other lobe is smaller, because here the electron density is more and here the electron density less. So this is S change its shape from spherical to double. Clear? Say yes or no. And P also change its shape like this. Got it? Say yes or no. And here you have to write sp. Means these orbitals are formed by hybridization. Which type of hybridization? sp. Now how many hydrogen here? Two hydrogen. And you know that hydrogen having only one electron. Say yes or no. So here also one hydrogen, and what will form? BeH2. And what is its geometry? Linear. And if it is linear, then angle is 180 degree. Everybody got it? Say yes or no.
Yes.
So this is beryllium.
Yes, ma'am.
Tell me, this is beryllium, ground state. This is beryllium, excited state. Then this is hybridization. This is hybrid orbital, and then they form bonding with hydrogen and BeH2 form. And what is its geometry? Its geometry is linear. So hybridization tell us about the geometry of the molecule also. So let's switch to this example, sp hybridization.
Let's learn about the formation of beryllium fluoride by sp hybridization. In this type of hybridization, one s and one p orbital mix to form two equivalent sp hybrid orbitals. The electronic configuration of beryllium atom is 1s2, 2s2.
Ground state.
In the excited state, one electron from the 2s orbital gets promoted to one of the two p orbitals. Now, one s orbital and one p orbital of beryllium atom undergo hybridization to form linear sp hybrid orbitals with a bond angle of 180 degrees. Each of these sp hybrid orbitals overlaps with two p orbitals of fluorine to form two sigma bonds between the beryllium and fluorine atoms in beryllium fluoride.
Now we are taking next example related to sp2 hybridization. So here they mention about BeF2 and I explain you related to BeH2. Clear to all, say yes or no?
Yes.
In fluorine, one of the orbital having one electron which require pairing. Clear? Now let's take the example. That is BCl3. Okay, so B means boron. Am I right? Say yes or no?
Yes, ma'am.
How many electron? 5 electron. What is its electronic configuration? 2, 3. Okay, then this is the ground state. Am I right? 1s, 2s, 2p. Clear to all, say yes or no?
Yes.
Then what will happen in next
Excited
state?
state.
Excited state. So this is ground state, then it goes to excited state. So in excited state, what will happen
One
with
electron will
the
move
one
to
of
p
the
orbital.
electron of this S
Will move
to
P orbital.
p orbital. Say yes or no?
Yes.
Now, which type of hybridization?
sp2.
Sorry,
sp2.
sp2 means 1s and 2
p.
p are. So what will happen here? Am I right? Say yes or no?
Yes, ma'am.
This remains at its position. This remains at its position. Clear to all? Say yes or no? And when 1s or 3 combine, what will happen? Say 3 lobes and this 3. And what you have to write here? sp2, sp2, sp2. Clear to all? Say yes or no?
Yes.
Now let's come to which? Chlorine. What is the electronic configuration of chlorine having how many electrons?
17.
What is its electronic configuration?
2, 8,
7. So we have to which orbital mainly take part in hybridization?
Last
Valency shell.
shell.
So we have to not take this, we have to take only this. So what is the electronic configuration of this 7? 3s2, then 3p x2, 3p y2 and 3z. What beta? 1. It means which here bonding with beryllium? This Z. Okay, got it? Say yes or no.
Yes.
So 1 chlorine, 2pz here, 1 here and 1 here. So it is trigonal. Am I right? Say yes or no. With angle of
1091.
no, with angle of 120. 120 degree. Clear to all? Say yes or no. Yes. Now give the feedback. What is this?
Boron. 5 electron.
It's
2, 3.
electronic 2, 3. Okay. So
Ground state.
ground state. Then from ground state moves to
Excited
excited.
state.
Then from excited to hybridization. In hybridization, this is the hybrid orbit, and this is overlapping with chlorine and form what? BCl3.
Three.
BCl3. And what is its geometry? Trigonal. Clear? Say yes or no. There is no repulsion because all bond pair here. No lone pair. Clear to all? Say yes or no.
Yes.
So now let's switch to next type of hybridization.
hybridization.
That is sp2.
Let's learn about the formation of boron trichloride by sp2 hybridization. In this type of hybridization, 1s and 2p orbitals mix to form 3 equivalent sp2 hybrid orbitals. The electronic configuration of a boron atom is 1s2, 2s2, 2p1. In the excited state of boron, one of the electrons from 2s orbital gets promoted to one of the 2p orbitals. Now, 1s and 2p orbitals of boron atom undergo hybridization to form trigonal planar sp2 hybrid orbitals with a bond angle of 120 degrees. Each of these sp2 hybrid orbitals overlaps with
Is
3
that
p
diagram
orbitals of chlorine to form 3 sigma bonds between the boron and chlorine atoms in boron trichloride.
Got it.
Can you play this again?
You all know very well when there is overlapping, head overlapping. Then this
Sigma
one is
bond.
sigma
Sigma
bond.
bond.
And when sidewise overlapping,
Pi bond.
pi bond. So in this condition, which type of overlapping takes place? Head overlapping. So how many sigma bond form in this condition? 3 sigma bond form. So now let's switch to another type of hybridization, that is sp3 hybridization. It means 1s and 3p. So we have to take an example of very common, that is methane. That is
Methane.
What is the formula of methane? C. Carbon. How many electrons in carbon? How many electrons in carbon? 6. What is this electronic configuration? 2,4. Okay, so here it is carbon, here 2, here 2, and here 1, 1. Am I right?
Yes.
So this is called its
Ground state.
state. 1s, 2s,
2p.
in excited state, what will happen? In excited state, one of the electron of what beta?
S orbital.
2s
orbital.
shifted to
P orbital.
clear. Now how many orbital half fill? 4. Take part in hybridization. sp3. Now you have to draw all these at one place. Yes or no? Why at one place?
Because
Because of the energy distribution. So 1, 2, 3, 4. So what is the shape of S plus Px plus Py plus Pz? So all these take part in hybridization and form this type of structure.
tetrahedral.
Yes, beta. Why these 3 small lobes? Where the electron density is low. Okay, now here 1, 2, 3, 4 and 4 what beta? Hydrogen. Now you able to know how many sigma bond form beta? 4 sigma bond form. Clear to all? Say yes or no? And
Yes.
here I have to write sp3. Inside this I have to write sp3, not inside this. Got it? Say yes or no?
Yes,
So it is mentioned that these are the hybrid orbit and which type of hybridization takes place here?
sp3.
sp3. So now let's see this.
Let's learn about the formation of methane by sp3 hybridization. In this type of hybridization, 1s and 3p orbitals mix to form 4 equivalent sp3 hybrid orbitals. The electronic configuration of carbon atom is 1s2, 2s2, 2p2. In the excited state of carbon, one of the electrons from 2s orbitals gets promoted to one of the 2p orbitals. Now, 1s and 3p orbitals of carbon atom undergo hybridization to form tetrahedral sp3 hybrid orbitals with a bond.
Show all three types of hybridization: sp, sp2 and sp3. When single bond present between two carbon, then hybridization is sp3. When double bond,
sp2.
and when
Triple
triple bond, sp hybridization. So you all, I have to explain you about this because here generally students perform mistake. Listen here very carefully. Suppose this question comes in your question paper that explain sp, sp2, sp3 hybridization in carbon. This type of question comes in your question paper. Explain sp3, sp2 and sp hybridization in carbon with the help of suitable example. So you have to draw figure like this. All of you pay attention here. First you have to write C is equals to 6 electron. Then you have to write its electronic configuration 2, 4. Then beta, first of all you have to draw this diagram. And this is same for all type of hybridization. Okay? What way here we write? What way here we write? What here we write? Energy. What we here write? 1s,
2s, 2p.
Okay, got it? Say yes or no?
Yes.
What we have to write below this? Ground
state.
And now you have to draw
Excited state.
3 excited state. What 3 excited state?
Carbon is
No,
sp2 sp3.
Wait. Here you have to write excited state like this. Am I right? Am I right?
Yes,
ma'am.
2p,
2s, 1s.
1s. And please mention this L. Now divide it into 3. Number 1 is sp3. Number 2 is sp2. And number 3 is sp3. Listen here carefully. In sp3 hybridization, these all take part. Say yes or no? Yes or no? So in sp3 hybridization, you have to draw diagram like this. Am I right? Am I right? Say yes or no?
Yes,
ma'am.
ma'am.
And in sp2, which type of diagram you have to draw? Sorry. Am I right? Say yes or no? Yes. Why one here? Why one here?
Energy different.
No, beta, because it is sp2. It means 1s
and
and
2p.
2p. And 1p remains at its position, not change. Okay, and what is in sp?
3, 4 hours.
No, 2. Only here 2 and 2 here. Got it? Say yes or no. So suppose this comes in your question paper. Explain sp3, sp2, sp hybridization in carbon. So you have to represent like this. Ground state same, excited state same, but only difference in their hybridization. Clear to all? Say yes or no. Yes. So keep it in your mind. Achha, now my question from you. Here which type of structure? Suppose it is
Tetrahedral.
C2H6. No, I am giving you C2H6. So which type of diagram to it? Which type of diagram?
Octagonal.
No octahedral, no tetrahedral. See here, how many carbon?
2.
How many carbon? 2. So, my dear, you have to draw like this.
Trigonal.
Beta, 1 minute, wait.
अच्छा अच्छा.
I drawn 2 carbon, say yes or no?
Yes,
2
ma'am.
carbon, say yes or no? 4 electron, 1, 2, 3, 4. Am I right? Say yes or no?
Yes, ma'am.
So what will happen? One overlapping here, say yes.
Yes, ma'am.
How many hydrogen here? 6. 1, 2, 3, 4, 5, 6. It means C, C, H, H, H. Am I right? Say yes or no? So how many sigma bond present in this?
1 2 3.
How many sigma bond
Six.
present?
Seven.
6 or 7?
Seven.
7 sigma.
Seven.
Why 7 sigma bond, not any pi bond?
Because
they have overlap. Head to head overlap. In this condition, which type of carbon diagram? Listen. These three.
अच्छा 1s 2p.
Wait.
Trigonal plane है.
Why inside only these three? I put 3 small lobes. Yes, Lakshya. Why inside these 3 we put the small lobes?
Because low densities. Less.
Unrelevant answer. Because which type of hybridization?
sp2.
So what you have to write here? sp2. Here you write.
sp2.
Here you write.
sp2.
Why not inside this? Why not inside this?
Because we are electron density.
Why not inside this? Because they do not take part.
Part.
Got it? Say yes or no. If you perform this silly mistake, I reduce your marks. Clear?
Remember inside those orbitals were having low densities, no?
Here load
In
is.
that small.
Here only beta listen. Be serious. This is the hybridization. Which type of hybridization? sp2. So these 3 orbitals change their shape. Say yes or no. 1s and 2p. Why inside there these small lobes? Because during hybridization, one lobe is bigger and other is smaller with low density. So here, why I have to write sp2 and not inside this? Because it do not take part in hybridization. Got it? Say yes or no. So it is very essential that only in these 3 lobes you have to write sp2. Clear? Another, we have to take the example of C2H4. Which example?
C2H4.
Another 2 carbon here, say yes or no.
Yes, ma'am.
So you have to draw another carbon like this, say yes or no.
Yes, ma'am.
Now tell me Laksh, where I have to write sp2.
In this.
In this,
Bigger lobe.
in this,
Yes,
in
and
this.
yes, yes.
Am I right? Say yes or no.
Yes, ma'am.
Clear to all, say yes or no.
Yes, ma'am.
How many hydrogen here?
4.
1,
2
2,
and those 2. Yes.
3,
4.
4.
Overlapping.
Overlapping. Clear, say yes or no.
Yes, ma'am.
So it will turn this. Say yes or no.
Yes, ma'am.
Now this sidewise overlapping, say yes or no.
Yes, ma'am.
So you have to put one another bond, but it contain how many sigma?
5.
How many sigma?
Five.
Five.
And
how
one
many
pi
bond.
One. Clear to all. Now who is able to draw diagram related to this? This is
SP.
C2H2.
H2.
This is
C2H2.
Okay. C2.
H2.
Which type of hybridization in C2H2?
SP.
SP, say yes or no?
Yes, ma'am.
It means this is S, this is
P.
Here to all, say yes or no?
Yes, ma'am.
PY as it is.
PZ
as it is. So where I have to write SP?
In that
In the horizontal.
Clear, say yes or no?
Yes, ma'am.
Another carbon also?
Yes,
Another
ma'am.
carbon also? So this another
Three.
carbon.
3 sigma and 2 pi bonds.
Clear? Say yes or no.
Yes.
SP, 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 and here no. So what will happen? This overlap. Say yes or no.
Yes, ma'am.
This overlap. Say yes or no. Which type of bond is formed?
Pi bond.
Pi bond. Is this overlap? Say yes or no.
Yes,
Yes, ma'am.
Again, which bond is
Pi
formed?
bond.
Pi
Pi
bond. And this overlapping forms
Sigma
bond.
And how many hydrogen? Two. So one here and one here. So what will form? C triple bond H and H. So how many sigma in this?
Three.
And how many pi
Two by
in
one.
this? So how many sigma?
3.
3. And how
Two
many
by one.
pi? Beta 2. Got it? Say yes or no.
Yes,
So
ma'am.
what you learned today?
Hybridization.
Let's recap. What we learned?
Hybridization.
What are the conditions essential for hybridization? Only valence shall participate in hybridization. And these shall having
Similar shape and
similar
same
energy. And during hybridization, it is not essential that empty or half-filled orbitals take part. Empty, half-filled, full-filled, all take part in hybridization. Then we learn about what is the contribution of or how much contribution of S and P during hybridization. So in SP hybridization 50-50%, in SP2 33-66 and in
25.
25 and 75. Okay, and then what are the example related to that? In SP hybridization BBH2 or BEFL, and in SP2 BCl3, and in SP3 hybridization CH4. Then which element is able to show all three types of
Carbon.
hybridization?
Carbon.
That is carbon, and then it show SP when triple bond present between two carbon. And this three triple bond, one is sigma and two pi bonds. And when double bond, one sigma and one
pi
pi.
bond.
And you know that C2S6 for having all
All
bond
sigma
sigma. And in which condition sigma bond is formed? When overlapping is head to
Head.
head. And in which condition
Side by side.
pi bond form?
Side by
Sidewise overlapping. Got it? And which is strongest among sigma and pi?
Sigma.
Sigma is the strongest because head to head overlapping, and in pi
Sidewise.
sidewise overlapping. Clear? And keep it in this mind. कि double bond compounds generally show additional reaction. Why they show additional reaction? Because they want to move out from stress which is due to double bond. So when once pi breaks,
2 sigma.
two sigma forms. So this is a very good objective. When one
Pi base 2 sigma
two
forms.
sigma forms. Clear to all?
Yes, ma'am.
And generally, if the compound having all the sigma bond, then it gives substitution reaction. So, are you able to frame 20 objective questions from this content? Say yes or no.
Yes,
Remember
ma'am.
who gives this concept?
Pauli.
The orbitals which are formed are called hybrid
Hybrid
orbitals. And the process is called
Hybridization.
How many type of hybridization?
Three.
Is not 3 beta.
Four.
Some more sp3d, sp3d2, sp3d3, but it is in 12th standard. So up to your syllabus it is. Or what is the role of this hybridization? It geometry of the molecule. Okay, it is for geometry of molecule. If no lone pair, only bond pair, then if only bond pair, then if BeH2, only bond pair, then angle is 180 degree. Okay, and is the angle deviated by bond pair and lone pair of electrons? Yes.
Yes.